Today we're going to distinguish between different types of quadrilaterals. In fact, special quadrilaterals. Remember that a quadrilateral is simply a four-sided polygon, a polygon with four sides. If we get any more specific than that, we can break it down into three types of special quadrilaterals. One type, the parallelogram family. A second type, the trapezoid family, and the third type, the kite family. So here you have a big flow chart of the special types of quadrilaterals. Starting at the top, you have the less specific types of quadrilaterals. Less specific at the top, more general. Less specific at the top, down to the bottom, you have more specific. So we have three types of special quadrilaterals: the parallelograms, the trapezoids, and the kites. Think of them like the cousins. The quadrilateral, like the great-grandfather. Then you have the cousins, parallelograms, trapezoids, and kites. They're related to each other in that they're all quadrilaterals, but they have more distinct characteristics. If we just focus on the parallelogram family, we get more specific as we say, well, a parallelogram could be a rhombus or it could be a rectangle. And you put the two together and you get the baby square, the most specific type of parallelogram. From the trapezoid family, you can get more specific and get isosceles trapezoids. And then the cousins, the kites, just one kind of kite, it's called a kite. Let's take a look at the parallelogram family and remember these characteristics. Perhaps you pause the video and see if you can fill in these blanks by yourself. Come back and check if you were correct. Parallelogram has both pairs of opposite sides congruent and both pairs of opposite sides are parallel. I should have put it the other way. Parallelogram is defined by the opposite sides being parallel, then we say that the opposite sides are congruent. Not that it matters which way we say it. I just like to put parallel first because that's what makes a parallelogram. The opposite angles are also congruent. The consecutive angles are supplementary. Remember, those are the two angles next to each other. This angle adds up to 180 degrees. Diagonals bisect each other. One pair of opposite sides, if we're just looking at one pair, must be both parallel and congruent. If we focus on just the rhombus part of the parallelogram family, we know that all of the above are true because it's a type of parallelogram, but most specifically it has four congruent sides. The diagonals are perpendicular, and each diagonal bisects the opposite angles. If the parallelogram instead is a rectangle, it has everything from above, all of those characteristics, but in addition, it has four congruent angles. To be more specific, we know those four angles must be 90 degrees. The diagonals are congruent. If we combine the rhombus with the rectangle, the baby square is born. That's the child of the rhombus and the rectangle. So it has all the properties above, including the most famous characteristics, four congruent sides and four congruent 90-degree angles. Let's take a look at the trapezoid cousins. Trapezoid is defined by one pair of opposite sides being parallel, just one pair. So it's like its family cousins, the parallelogram, where both pairs are parallel. In the trapezoid family, only one pair is parallel. Remember, those are called the bases. This guy right here, this guy right here. Just one pair is parallel. Let's write that those are called the bases. Two pairs of consecutive angles are supplementary. just 2 because we have fewer parallel lines, unlike a parallelogram where all the consecutive angles are supplementary. Make our trapezoid isosceles, and the non-parallel sides, which are the legs, are congruent. These are called the legs, those non-parallel sides. The diagonals will be congruent, and both pairs of base angles are congruent. Visually, well, you've got a lot of other visuals in your notes, but here are the parallel bases. The legs are these two guys that are not the parallel sides, but in an isosceles trapezoid, those will be the congruent ones. And then you have the base angles along one base congruent and the base angles along the other base congruent. A mid-segment of a trapezoid is parallel to each base. So if I draw the mid-segment, midpoint here, we don't assume that it's an isosceles trapezoid. We show that it's parallel to both bases. We show that the length of it is right in the middle of the other two. So how do we say right in the middle? Half the sum. That's because we're doing the average. Base plus base divided by 2. That's the average. Okay? Let's take a look at the kite cousins. The kite cousins, a kite is defined by two pairs of consecutive sides, such as this side and this side, congruent, or this side and this side, congruent. The diagonals are perpendicular. Remember, flying a kite, you get that T-shaped wooden structure. Exactly one pair of opposite angles are congruent as well. Those are the angles between the non-congruent sides across from each other.